Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here is the essay based on your detailed instructions. Rudolf Virchow's Cellular Pathology is based upon Physiology and Pathology, published in 1858, stands as a seminal work in the history of medicine. This treatise fundamentally reshaped the understanding of disease by asserting that all pathological processes originate within cells, abandoning the prevailing humoral theories and shifting the focus from organs and tissues to the microscopic level. Virchow established cellular pathology as the cornerstone of modern pathology. This essay undertakes a deep, critical evaluation of the claims presented within Virchow's magnum opus, examining the logical coherence of his arguments, the evidence he provided, and the lasting impact of his cellular doctrine. The analysis proceeds section by section, offering a comprehensive assessment of Virchow's revolutionary Section 1 Introduction to Cellular Theory, and the rejection of humoralism. Virchow initiates his treatise with a forceful rejection of the ancient humoral theory which attributed disease to imbalances in bodily fluids. He directly confronts the prevailing notion that disease represents a disruption of the organism as a whole, arguing instead for a localized cellular origin of pathology. This section meticulously lays the groundwork for the cellular theory, emphasizing that the cell, as the fundamental unit of life, must also be the starting point for understanding disease. Virchow underscores that the organism is a cellular state, or community in which every cell must possess its own independent vital activity rather than a unitary whole dictated by some mysterious force. He claims that pathology is nothing more than physiology with obstacles. A critical evaluation reveals how Virchow utilizes Occam's razor, advocating for a simpler explanation of disease rooted in observable cellular changes rather than abstract imbalances. This stance, while revolutionary, was not without its critics, who clung to holistic views of the organism. It's amusing to note how Virchow, in his spirited dismantling of humoralism, effectively performed a post-mortem on ideas that had persisted for millennia, showing them to be quite deceased. Section 2 Omnis Cellula e Cellular, the doctrine of cell lineage. One of the central tenets of Virchow's cellular pathology is the principle of omnis cellula e cellula, meaning every cell arises from a pre-existing cell. This concept directly challenges the then popular notion of spontaneous generation, which posited that cells could arise de novo from null cellular material. Virchow's assertion is that cells only multiply through the division of existing cells. This claim, while seemingly straightforward, has profound implications for understanding the origin and spread of diseases such as cancer. Throughout this section, Virchow presents evidence from microscopic observations of cell division, demonstrating the continuity of cell lineages. Modern cell biology has affirmed the validity of Virchow's assertion, confirming that no cell arises independently. However, Virchow's initial understanding of cell division was incomplete. He lacked the knowledge of the complex processes of mitosis and meiosis, which were later elucidated by other scientists. The irony here is that Virchow's emphasis on cellular continuity provided the foundation for understanding these later developments, even though his own grasp of the mechanisms was limited. Section 3 Cellular alterations as manifestations of disease. Virchow meticulously describes various cellular alterations that occur in disease states. These include changes in cell size, shape, staining properties, and proliferative capacity. He emphasizes that these alterations are not merely secondary consequences of disease but, instead, are the primary manifestations of the pathological process. For example, Virchow details the cellular changes observed in inflammation, arguing that the influx of leukocytes and the proliferation of connective tissue cells represent the body's response to cellular injury. He discusses hypertrophy, where cells increase in size, and atrophy, where cells decrease in size. He also describes metaplasia, where one cell type transforms into another. This section reveals Virchow's keen observational skills and his ability to connect microscopic findings with macroscopic disease manifestations. It underscores his belief that a thorough understanding of cellular changes is essential for accurate diagnosis and effective treatment. The section acts as a kind of cellular catalogue of horrors, displaying the manifold ways in which cells can betray their Section 4 Inflammation and Pus Formation. A cellular perspective. Virchow dedicates considerable attention to the cellular basis of inflammation and pus formation. He directly challenges the prevailing view that pus is a product of spontaneous generation or a general systemic reaction. He theorizes that pus is composed of leukocytes, which migrate from the blood vessels into the inflamed tissue. This infiltration of leukocytes, according to Virchow, is a critical component of the inflammatory response. He carefully describes how leukocytes accumulate in the affected area and how they contribute to the breakdown of tissue and the formation of pus. This cellular explanation of inflammation represented a significant departure from traditional views, which emphasize the role of humoral imbalances. It is noteworthy that Virchow's view was not universally accepted at the time. Some physicians continue to view inflammation as a systemic process, rather than a localized cellular response to injury. However, the modern understanding aligns closely with Virchow's cellular Section 5 Thrombosis and embolism. Cellular aspects of vascular disease. Virchow delves into the cellular mechanisms underlying thrombosis and embolism, two major causes of vascular disease. He theorizes that thrombi, or blood clots, form due to alterations in blood composition, blood vessel walls, or blood flow. He identifies specific cellular components of thrombi, including platelets, fibrin, and leukocytes. Furthermore, Virchow elucidates the process of embolism, where a detached thrombus, or embolus, travels through the bloodstream and lodges in a distant vessel, obstructing blood flow. He connects these processes to cellular alterations in the blood and blood vessel walls. He hypothesizes that damage to the endothelium, the inner lining of blood vessels, promotes thrombus formation. This section demonstrates Virchow's ability to apply the principles of cellular pathology to understand complex vascular diseases. It is interesting to reflect, in light of modern understanding, how Virchow's insights laid the groundwork for developing anticoagulant therapies and strategies to prevent thromboembolic events. Section 6 Tumors and Cancer. A cellular theory of neoplasia. Virchow's cellular pathology profoundly influenced the understanding of tumors and cancer. He rejects the prevailing belief that tumors arise from blastoma, a formless embryonic tissue. Instead, he asserts that tumors originate from pre-existing cells that have undergone abnormal proliferation. He argues that cancer cells are not fundamentally different from normal cells, but that they have simply lost their normal regulatory mechanisms. Virchow classifies tumors based on their cellular composition and their degree of differentiation. He describes benign tumors as those that are composed of well-differentiated cells and that grow locally without invading surrounding tissues. He defines malignant tumors, or cancers, as those that are composed of poorly differentiated cells and that are capable of invading surrounding tissues and metastasizing to distant sites. This section marks a turning point in the understanding of cancer, shifting the focus from mysterious forces to cellular abnormalities. Subsequent research has built upon Virchow's foundation, elucidating the genetic and molecular mechanisms that drive cell proliferation and tumor development. Section 7 Atrophy and Degeneration. Cellular responses to injury. Virchow explores the cellular mechanisms underlying atrophy and degeneration, two common responses to injury. He differentiates between simple atrophy, where cells decrease in size due to reduced workload, and pathological atrophy, where cells shrink due to disease processes. He also describes various forms of cellular degeneration, including fatty degeneration, amyloid degeneration, and hyaline degeneration. Virchow attributes these changes to alterations in cellular metabolism and to the accumulation of abnormal substances within cells. He notes that these degenerative changes can impair cellular function and contribute to disease. This section exhibits Virchow's attention to detail and his ability to discern subtle differences in cellular morphology. It also underscores his belief that cellular changes are the key to understanding the pathogenesis of disease. The irony, perhaps, is that even as cells degenerate and atrophy, they continue to bear witness to the validity of Virchow's cellular principle. Section 8. The limitations of cellular pathology. Acknowledging the whole organism. Although Virchow's cellular pathology focuses on the individual cell as the seat of disease, he acknowledges the importance of considering the organism as a whole. He recognizes that cells do not operate in isolation and that their behavior is influenced by their surrounding environment and by interactions with other cells. He admits that some diseases may involve systemic factors that cannot be entirely explained by cellular changes, though he maintains those external factors are only acting upon the cells. Virchow emphasizes the need to integrate cellular findings with clinical observations and with knowledge of physiology and anatomy. He cautions against reducing disease solely to cellular events, reminding readers that the organism is a complex and interconnected system. This section serves as a caveat to Virchow's cellular doctrine, highlighting the importance of a holistic perspective. It would be easy to paint Virchow as a radical reductionist. This section reveals a more nuanced understanding of the complexity of Section 9. Cell-to-cell interaction and the microenvironment. Virchow's work indirectly addresses aspects of cell-to-cell interaction without fully exploring the modern concept of the microenvironment. Later discoveries refined these ideas, and it is important to evaluate them in the context of Virchow's work. He alludes to the importance of the surrounding tissue and the influence of neighbouring cells, but does not fully capture the complexity of cell signaling, extracellular matrix components, and immune interactions that constitute the microenvironment. He does, however, establish a foundation for understanding how cells communicate and influence each other during pathological processes. This section can be viewed as a precursor to a more complete understanding of tissue organization. Section 10. Specificity revisited differential cellular responses. Virchow recognizes that different cell types respond uniquely to various insults or pathological stimuli. This understanding of differential cellular responses is a crucial component of cellular pathology. Virchow observes that tissue sensitivity and cellular susceptibility vary significantly, leading to diverse disease manifestations. He notes that some cells are more resistant to certain forms of injury, while others are highly vulnerable. He uses these observations to explain the selectivity of certain diseases for specific tissues or organs. This section emphasizes the complexity of cellular pathology and the need to consider the unique characteristics of each cell type when studying the Section 11. Influence on microbiology and infectious disease. While Virchow's cellular pathology focused on the cellular response to disease, it also impacted the nascent field of microbiology. Despite some initial disagreements with Pasteur, Virchow's emphasis on the cellular nature of disease provided a framework for understanding how infectious agents interact with host cells. He observes that bacteria and other microorganisms can invade cells, disrupt cellular function, and cause cellular damage. Although Virchow debated with proponents of germ theory, his emphasis on cellular pathology provided a crucial link between microbiology and the understanding of infectious diseases. The subsequent development of germ theory by Pasteur built upon Virchow's cellular framework, integrating the role of microorganisms with the understanding of cellular pathology. Section 12. Legacy in modern pathology and beyond. Virchow's cellular pathology has had an enduring impact on modern medicine. It has provided the foundation for modern pathology, histology, and cell biology. His emphasis on microscopic observation and cellular analysis has become the cornerstone of diagnostic medicine. The principles of cellular pathology are applied in virtually every field of medicine, from oncology to infectious disease. The modern understanding of cancer, inflammation, and degenerative diseases is deeply rooted in Virchow's insights. His work also laid the groundwork for the development of new therapies that target specific cellular processes. Virchow's legacy extends beyond the laboratory, influencing public health and disease prevention efforts. Section 13. The evolution of cellular concepts since Virchow. Since Virchow's groundbreaking work, cellular pathology has evolved significantly in response to advances in molecular biology, genetics, and imaging technology. While Virchow focused primarily on morphological changes, modern cellular pathology also encompasses the molecular and genetic alterations that underlie disease. Sophisticated techniques such as immunohistochemistry, flow cytometry, and molecular diagnostics are now used to characterize cellular abnormalities at the molecular level. These advances have provided new insights into the mechanisms of disease and have led to the development of targeted therapies. The evolution of cellular pathology reflects the ongoing pursuit of a deeper understanding of disease at the cellular and molecular level. Section 14. Re-evaluation of irritation as cellular stress. Virchow's original concept of irritation leading to altered cellular behavior can be re-evaluated in the light of modern understanding of cellular stress. He viewed cellular changes in response to irritation as a disturbance in cellular equilibrium rather than a defined set of stress responses. Modern cell biology provides a far more detailed view of cellular stress mechanisms, including the unfolded protein response, oxidative stress, and DLA damage response. It is now apparent that cellular responses to stress are highly regulated. While Virchow did not have the benefit of these insights, his initial recognition of cellular irritation paved the way for understanding the complex ways in which cells respond to their environment. Section 15. Cellular heterogeneity and the importance of subpopulations. Virchow's cellular pathology considered cells largely as a homogeneous population, overlooking the importance of cellular heterogeneity. Now, it is recognized that populations of cells within a tissue or tumor often exhibit significant variability in their morphology, gene expression, and behavior. Cellular heterogeneity can arise due to genetic mutations, epigenetic modifications, or differences in the microenvironment. The identification and characterization of cell subpopulations have become increasingly important in understanding disease. For example, in cancer, the presence of cancer stem cells can contribute to tumor growth and resistance to therapy. Contemporary pathology techniques now allow for better recognition of cellular diversity, enriching our understanding of how diseases are initiated and sustained at the cellular level. Section 16. The nervous system and cellular pathology. Virchow touched upon the cellular structure of the nervous system, acknowledging the presence of nerve cells, but his work did not fully integrate the understanding of neural signaling and their impact on pathology. The contemporary view recognizes neurons, glial cells, and their interactions as critical aspects of both normal physiology and disease. Neurodegenerative diseases, such as Alzheimer's and Parkinson's, are now deeply understood at the cellular and molecular level. The understanding of these diseases has been greatly advanced by modern cellular approaches. Section 17. Cellular pathology and the immune system. Virchow's cellular pathology considered leukocytes in the context of inflammation, but his work predated the sophisticated understanding of the immune system that is now available. The modern understanding of immunology reveals the complexity of immune cell interactions, the role of cytokines and chemokines, and the mechanisms of adaptive immunity. The contemporary view recognizes the immune system as a dynamic cellular network that plays a central role in many diseases, including infectious diseases, autoimmune disorders. Section 18. The concept of cellular adaptation. In Virchow's work, Virchow recognized that cells can adapt to changes in their environment through processes such as hypertrophy, atrophy, and metaplasia. However, the scope of adaptation now includes a wider array of changes, including epigenetic modifications, altered gene expression, and metabolic reprogramming. Modern cell biology reveals that adaptation is a complex process, governed by multiple cellular and molecular mechanisms. The contemporary understanding of adaptation provides new insights into the ability of cells to survive and function in the face of stress or injury. Section 19. Virchow's influence on toxicological pathology. Virchow's cellular pathology laid a basic groundwork for understanding how toxic substances exert their effects on the body, but lacked specific knowledge about cellular mechanisms of toxicity. Modern toxicological pathology has delved into the molecular details of how toxins interact with cells, disrupt cellular processes, and induce cellular damage. It recognizes the importance of cellular responses to toxic exposure, including DNA damage, oxidative stress, and apoptosis. Virchow's legacy provides the foundation, with the contemporary fields building upon it by exploring intricate cellular interactions. Section 20. The enduring relevance of morphology. Throughout all the advances in modern pathology, it is essential to note the lasting impact of Virchow's emphasis on cellular morphology. Although molecular and genetic analyses now play a critical role in understanding disease, the fundamental principle of examining cellular structure remains essential. Microscopic evaluation remains the cornerstone of diagnostic pathology, providing insights into disease processes that cannot be obtained through other methods. New imaging technologies have enhanced the ability to visualize cellular abnormalities, reinforcing this relevance. Conclusion. Rudolf Virchow's cellular pathology as based upon physiology and pathology stands as a transformative work that forever changed the landscape of medicine. His assertion that all diseases originate within cells, his articulation of the principle of omnis cellula e cellula, and his meticulous descriptions of cellular alterations in disease have had an enduring impact on modern medical science. While modern research has expanded upon and refined Virchow's initial insights, it has not diminished the fundamental importance of his cellular doctrine. He offered methods and a way of analyzing biological matter that retains value to this day. Virchow's emphasis on microscopic observation, his attention to detail, and his commitment to scientific rigor continue to inspire generations of scientists and physicians. His work serves as a testament to the power of observation, the importance of critical thinking, and the enduring relevance of cellular pathology in the understanding and treatment of disease. His influence extends far beyond the confines of the laboratory, shaping public health policy and influencing the direction of medical research. The legacy of Rudolf Virchow persists not merely as a historical footnote, but as an active and vital force in shaping the future of medicine.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.